The combustion question, you have an organic compound T containing only carbon, hydrogen, nitrogen, and oxygen, only 4 elements. Okay, in the first investigation, so we have 2 investigations in total. The first one says percentage of nitrogen in T may be determined by the reaction of T with hot sodium metal. Okay, so to convert any nitrogen to sodium cyanide, Cn. Okay, so the first investigation is to convert N, the nitrogen, into Cn, cyanide. Okay, this is for the first investigation. Okay, second investigation, percentages of hydrogen and carbon is found by measuring the mass of carbon dioxide and water produced in the combustion. Okay, so two different investigation. The first one is to determine percentage of nitrogen. Okay, so let's zoom in on the first investigation. 0.4576 gram of T react with excess sodium to form this amount of sodium cyanide. Okay, so the question wants us to calculate percentage by mass of each element. Nothing was said about oxygen, so most likely we have to find the first 3 elements and then just 100% minus off the first 3. Alright, so the first one, mole ratio of cyanide to N is 1:1. So we actually just need to find the number of moles of nitrogen first, and then just multiply by the AR of nitrogen. That will give you the actual mass. Okay, so this actual mass divided by the initial sample mass, okay, times 100% will give you 11.4%, okay, of nitrogen in T. So this is from the first experiment. Okay, let's move on to the second experiment. Again, we're using the mole ratio, right? Because carbon dioxide to carbon, the mole ratio is 1:1. Okay, whereas for hydrogen, it is 1:2. We just need to take note of the mole ratio when we are doing our calculation. Okay, so number of moles of carbon, we take 0.229. Okay, this is information given from the question here. Okay, so this is the volume of carbon dioxide. We divide by 22.7 because it is at STP, right? So this is the number of moles of carbon in carbon dioxide. Since the mole ratio is 1:1, we can just multiply by 12 to get the actual mass. Alright, so this actual mass, go and divide by the initial mass of the sample for second investigation, right? Second investigation is actually 0.21 grams. 0.21 grams. Okay, so you got about 57.6%. This is the percentage of carbon in the second sample. Okay, then second investigation, beg your pardon. Okay, then for hydrogen, right, we need to find number of moles. Again, we just take, okay, the data given is 0.00427 moles of water. Okay, so we multiply by 2, right, we will get the number of moles of hydrogen. Okay, because we are interested in the percentage of hydrogen, not water. Okay, so multiply by 2 already, we just multiply by 1 again. Actually, it's the same thing. So this is the actual mass of hydrogen in the sample. Okay, we just need to divide by 0.21 grams times 100%. This will be the percentage of H in sample T, which is 4.07. And then oxygen, all you need to do is 100% minus off all of these other elements. You will get 26.9%. Okay, this is a relatively straightforward combustion question. The question actually guided you through 2 investigations to find out the number or moles of 3 elements, right? Then the fourth one, just 100% minus off the earlier 3 percentage, you will get the percentage of oxygen. Okay, if you have any question, please feel free to leave a comment and ask your question. See you in the next one.